of inverse tangent of x is equal to 1 over 1 plus x squared. There you go. Another trophy to hang on our wall here. Inverse tangent of x is 1 over 1 plus x squared. Derivative of inverse tangent is 1 over 1 plus x squared. This one's actually easier than the sine one because we didn't have to solve for this. We had to think about the square root, you know. Let's see here. Any other inverse functions you guys want to find the derivative of? How about inverse hyperbolic sine? Could do that one. All right, so what's my opening move? Y equals to the thing we're trying to differentiate, right? Again, next move, solve for x. So sinh of y equals to x. What do we do next? We differentiate implicitly. Right, differentiate implicitly, just like we did last time. So I have d dx of sinh y equals to dx dx, right? Which tells me that cosh of y times dy dx is equal to 1. So then I can solve for dy dx, right? Now we're faced with the question, how do we relate that to sinh, right? How are cosh and sinh related? Well, I'll remind you. Cosh squared y minus sinh squared y is equal to 1. If you doubt this, you should spend 5 minutes to derive it. It's not hard to work out in terms of the exponentials. Now, sinh of y was what? It was x here, right? So this says that cosh squared y is equal to 1 plus x squared, actually. Right? Using this here to take that and add it to the other side. And so what's cosh equal to? Yeah, cosh y is square root of 1 plus x squared. So what do we got? Put that up in here, right? And then we have the following result. We have d dx of inverse hyperbolic sine 1 over the square root of 1 plus x squared. Now, that's not something I have memorized personally, but it is something I'm ready, willing, and able to derive if I need to. All right. In contrast, it is expected that you have memorized the derivative of inverse sine and inverse tangent. Like, those are pretty standard results that calculus students are supposed to know. There is a rather different way to do this problem that I think is worth spending a minute or two of time on. I have a homework problem. So there's a homework problem. I'm going to try to help you with a homework problem in advance here. So the one I'm referencing is problem 94. So what I just did, so problem 94 is the same question, but for inverse hyperbolic cosine. And so what I've just done is essentially what I expect you to do an analogy of for hyperbolic cosine part A. Like part A, that's the 4 or 5 step. This is the 4 or 5 step algorithm I'm talking about. Like step 1 is write this, step 2 is solve for x, step 3 is implicitly differentiate, step 4 is solve for dy dx, and then step 5 is to use knowledge about the function to clean up the formula. That's the 5-step program to find the derivative of the inverse function. And we just put that into practice here for inverse hyperbolic sine. There is another way. And the other way is to do some algebra. Algebra way. So you've got, and it's good for you guys to see this, but it is challenging. So inverse sinh equals to y. So what I'm going to do is I'm going to, well, pretty much go down the same set of steps, but not the calculus part. So I do x is equal to sinh y, right? And then that is 1/2 e to the y minus e to the minus y. I multiply by 2. So what that gives me is 2x is equal to e to the y minus e to the minus y. Then I multiply by e to the y. This gives me 2xy, well, excuse me, gives me 2x e to the y equals e to the y squared minus e to the y. Well, what's e to the y times e to the minus y? What is e to the y times e to the minus y? I'll write it out. E to the minus y times e to the y. What's that term? No idea? You want to take a stab at it, Taylor? Jake? Tyler? I can imagine. No? I once gave a lecture to like 2 imaginary students just because I felt like it would make the lecture better than if I was just talking to no students and making a video. What is e to the minus y equal to? I'm afeared I was out of frame. Oh, no, not yet. It's 1 over e to the y, right? This is e to the y to the minus 1 also, or 1 over e to the y, right? You guys know this. So this is exactly just the cancel, right? I mean, it leaves you with 1, right? Well, it does. And then so if we expand, we rewrite this, we got e to the y quantity squared minus 2x e to the y plus 1 equal to 0. Now, so let me just tell you what I'm after here. What I've been doing, my goal here, solve for y. I'm trying now to solve for y. But I don't just want to go back to y equals inverse hyperbolic sine of x. That doesn't really get me anything. I'm trying to solve for y in a different way. And you see what I can do? We have what? We have something squared, a number times the something plus a number again. I mean, if you look at this, this is quadratic in e to the y. So we make like a, you know, what do you want to make? Z squared minus 2xz plus 1 equal to 0, right? Make a z equals e to the y substitution just to see it. And this we can factor, complete the square actually. So I've got z minus x quantity squared, minus x squared plus 1 equal to 0, completing the square. And so I get z minus x squared equal to x squared minus 1. So that gives me z minus x equal to plus or minus the square root of x squared minus 1, which gives me that e to the y is equal to x plus or minus the square root of x squared minus 1. Putting back into z equals e to the y and solving for it. And then what? Take the natural log of the equation, right? And, well, for this to be, if you think about this for a second, can this be plus or minus? Well, this is what? I think I may have made a, did you see some, where do you think was wrong? I saw you look, you had to look. I feel like that's supposed to be x squared plus 1. I think I made a sign error somewhere in the steps here. If that's a minus in see that? Then it can't go to plus and plus like that. This is supposed to be minus right here. So yeah, it was x squared plus 1. My bad. So x squared plus, just change the minuses to pluses here. So that's what we got. And if you think about it, we have to choose the plus. Otherwise, we'd have e to the y equals something negative. All right? So choose the plus, and we've got natural log of e to the y equals the natural log of x plus the square root of 1 plus x squared, or x squared plus 1, rather. Right? And so there you go. This is a formula, a straight-up formula for inverse hyperbolic sine. Inverse hyperbolic sine of x is actually the natural log of x plus the square root of 1 plus x squared. Now, that's... And so how do you differentiate inverse hyperbolic sine? Can you differentiate that formula? I mean, we can, right? So we do 1 over x plus the square root of 1 plus x squared, and then times the derivative, which is 1 plus 2x over twice the square root of 1 plus x squared. And it's not obvious, but if you do some algebra on this, you can get back to that. I think I may be out of time. So. It's bothering me, though. How would you make a common denominator here? Well, we cancel the 2's here, right? We have this square root of 1 plus x squared plus x divided by the square root of 1 plus x squared. That's this piece. All right? Times 1 over x plus the square root of 1 plus x squared. So what do you get? You get that. I admit, at like first glance, the derivative does not look the same, right? And did you follow the derivative? That was kind of fast, what I just did here. So I differentiated this. I did the chain rule for the natural log. Then I had to differentiate the inside function, and I had to use the chain rule for the square root function inside that. But anyway, which do you think is a better way to calculate the derivative of the inverse hyperbolic sine? First one. Yeah, I think the first one's easier. But I asked you to do both in the homework because I think it's important for you to be aware of these formulas And it's a good algebra exercise to work it out. There's a similar formula for hyperbolic cosine. There's actually also a similar formula for inverse hyperbolic tangent. All of the inverse hyperbolic functions can be written as natural logs of algebraic functions. Anyway, I shut up. I will shut up.